Hi there, welcome back to the channel and welcome to the third video in the restoration of this Philips Antoinette, the famous Mon radio. Now, where we left off was I had everything on the AM working, FM was zero, okay? And I looked around, I procrastinated as much as I could, but ultimately I came to the decision that I had to remove the FM unit. No way of getting around that. I didn't want to do that. I don't like messing in those little things, but hey, sometimes you got to do what you got to do. And so this video is going to be entirely dedicated to a series of brain surgeries on that FM front end. Is the result going to be worth it? Hey, I'm not going to spoil it. Stick around, watch for yourself. Enjoy the video. Just as I expected, I had to remove that front again. I took the dial glass off because I needed access to the FM unit. I'm going to have to remove the FM unit. I can't figure out what's wrong with it, with this thing in its case. And to do that, I had to remove the pulley. I tried to put some tape on there so that these wires don't all just come loose, and I'm not sure that that's going to work too well. But I've got the dial string diagrams, so I'm sure I can put them back later. I just wanted to avoid it if I could. I need to get those two screws out so that the actual pulley just comes forward. And it took quite a bit of backwards and forwardsing. It's not that easy. Now I can actually get hold of those screws, get them out. The screwdriver is slightly magnetic, so I'm counting on that to prevent these screws from falling into the chassis. It's always a pain to find them afterwards. There are two screws on that. And then it should just come forward. Okay, there we go. And I've got a feeling this whole thing's going to unwind sooner or later. Never mind. Now there are two screws behind that are holding the FM unit to the chassis. Got to get those two out as well. The second one I'm actually doing through the hole in the pulley. And there we go. At least that's done. And now this thing should come out. You have to sort of lever it up a bit because there's a protrusion on the front. But ultimately, yeah, it'll come out. And then I need to give those wires that come through to the unit. I had to release some of those wire ties just to make sure that I could get enough wire to be able to pull this far enough to be able to work on it. It was a bit messy trying to get this out, but I've finally got it done. It doesn't come out far enough to work on, but it's better than nothing. Not that you can see much more. You can't really see that much more on here. But it's better than nothing, as I said. And we'll see how to work on this thing now. I'm not sure where to go from here. But it'll tell me if I'm patient. Initially, I thought of taking some really good close photographs. I raised that paper lip a little bit. I wanted to see if I could relate this to the circuit diagram on the schematics on the service manual and work it from there. I got a real close up. This looks a bit of a mess, but we'll see. Well, that was quite an experience. I had to stop filming. I just could not do this at the same time as trying to record. But I'll tell you what I did. This thing was, as you will see if you look at the pictures, this was in here like that, okay? I had to remove all the wires. I desoldered all the wires. There's a capacitor here that I clipped. I made a drawing of where the wires went, took some notes so I can refer to them later. Always, always necessary. And then this comes out. And when this comes out, I wasn't sure how it would release from this mechanism, and I realized these guys, these ferrite cores, are actually soldered to the bottom over there. So when you do this, there's a little tooth, little gear that clips in there and brings this whole system forwards and backwards. And that's how you change the inductance of the cores. That's how you change your tuning. Pretty simple. So this stays intact and it gets moved aside. And here's the board. Now this board as it is, if I wired this all up, this wouldn't work because the inductors, these coils, have got no cores. The cores are here. And my idea was actually to remove this thing and be able to get it working on a bench. I may still be able to do it. My logic is that without these guys in there, this thing will oscillate at a different frequency, obviously. But it might not actually go into oscillation. It might actually require a little bit more inductance to make it oscillate in the first place, because I got a feeling it's the oscillator in here. Now, what do we have here? Well, I've actually looked at this very carefully under magnification, and I can't find any obvious breaks. At first, I thought somebody had messed with this, and I think maybe they didn't. Maybe this is how this thing was built. It's pretty poor, but hey, it worked. So who am I to criticize? But here's the top of the board. And again, I thought I got lucky when I saw these two guys very, very close together, but they're not actually touching. So there are two transistors here. One is the RF, I'm not sure which one it is right now, but one is the RF transistor and one is the mixer oscillator. I'll have to check that. I'll have to check connections. I'm going to look at the schematic and I'm going to check this thing component per component. I'm going to measure resistances. I'm going to have to desolder one leg at least of every component. I'm going to have to be very, very careful because these tracks are incredibly, incredibly sensitive and fine and fragile. But I'm going to use the soldering iron at a lower temperature and a solder wick and be very, very careful. I mean, at the moment, this thing's not working. So anything I do, well, I don't want to trash it, but I don't think it can get any worse. Famous last words, eh? The other thing I want to check is these capacitors. Now, I remember a friend of mine, Derek, had a problem with one of these trimmer caps that was either shorted or completely disconnected. One leg was disconnected. I remember he had a problem with that in the past. So I'll be taking those out and checking for capacitance, make sure that they're actually working. This is a very simple circuit. If you look at the schematic, there's nothing too complex about it. The complexity of this circuit and the reason working on it is tricky is because lead dress is important. The positioning of components and the way they interact with each other because of their physical layout is important. It changes stray capacitances, stray inductances, and suddenly something that's supposed to oscillate doesn't oscillate at all, or something that's supposed to oscillate at 110 megahertz doesn't at all. You know, I was getting a signal coming out of here, 64 megahertz, constant at the IF. So I think it's something to do with the oscillator. I actually tried to adjust these trimmers. I got no alteration on that frequency. So this left me with the final alternative, which was to remove this whole thing and check it component by component, connection by connection. I'm hoping that when I finish this layout will look a little bit neater and be working. And I'm also hoping that I'll be able to do those changes or do those checks and then test this by connecting wires to the respective points over there. I can check different sections one at a time. I don't need all the connections at the same time. But for example, these last three are the antennas. I don't need to connect that. So I'm looking at 1, 2, 3, 4, 5 connections. It's no big deal. It should be quite easy. I'll put this as close as possible to the radio. It won't have the shield on it. And the shield, of course, does have a great effect on the tuning, on the adjustments. But at the moment, what I'm trying to do is get this thing to work, and then I'll do the fine tuning afterwards when I put this thing back in there. Okay, let me get started. Procrastination by yakking. Yeah. Let me tell you what I've done so far. I removed this as you saw before. I started at the front end, started cleaning up the contacts, checking components, and I was about to go on to the second stage, which is the mixer oscillator. And I realized because there's an IF transformer here, or rather there's a tuning for the IF over here, I thought I'd better just check that. So I wired temporary wires to this thing. I literally took the wires from there, soldered a small length of wire to the corresponding connector over there. So I've got this thing back into the radio, although it's out, obviously. I have everything connected except the antennas, which I don't need, because I wanted to feed an IF frequency tone on here, see if it's getting through, see if I can optimize it, and let's see what happens. Now at the moment I'm doing things by ear. I've got this coming in to before the, well, where the oscillator would be. I want this before the transistor so I can get isolation between it and the tuning circuit, which is the top one there. And if I switch on the signal generator, I've got my tone. And I've lowered the volume a bit. I had to do this. I have no tuning tool for this. It's just a little sort of a cut on the end of a piece of stick. Mac, this is not a chopstick. Chopstick was too thick, but something similar. And there's the coil. As you can see, it goes down, goes up and down. So I've got my peak over here. So that was good. It's not final. It's not the final tuning, because obviously when you've got this thing in the chassis and everything else and on the radio, I'm going to have to make that adjustment again. Then I thought, wait a minute, let me switch off the signal generator. I thought, what if I, as I said to you, I thought this was the oscillator that was not working. I thought, what if I send a signal to it at the oscillator frequency? What will I get? So I got my ELV signal generator, stereo signal generator, and I'm going to connect it. I've got a little clip to the output over there. I'm not even using the ground. This is battery operated, so it's floating. And I'm going to connect it to the same point. I can hear the tone that this thing is generating. I can hear it as I move this around here. And then I thought, wait a minute, this thing is it's producing a signal. At the moment it's at 90.87 megahertz. But this could also be the oscillator frequency. So what I've done is I've gone down here to audio, modulation, and I'm going to mute the modulation. So all I've got now is a carrier. Now if I put an antenna on here, literally just a length of wire, just hang it off the edge here. What am I getting there? Listen to this. Put the volume up. Oops, I'm hearing something. Just a while ago, I was picking something up. Damn. The problem I've got is I don't know exactly what the components are underneath this. It's pretty difficult. Probably wondering why I'm insisting on 90.8. I'll tell you that in a minute. Yeah, I'm not going to get it to work. But the point is, what I'm getting is this thing's producing the oscillator frequency. And the reason it was working at 90.8 is I have a station, a strong one, in my area at 101.6. Now, because I was tuning to 90.8, I think I was getting this thing acting as, 10 megahertz below, which is the IF frequency, 10.7 below 101.6, and it was working that way. Then I tried something else. I got out my Nordmende, which is a pretty good FM receiver, and I am going to try and use this oscillator to tune that. So I'm just going to hang this over here, switch on FM. It's pretty strong, but I'll put the volume on 0. And as I said, I've got to find this spot to make sure that I get this going through the right place. Hear that? Distorted, but it's coming through. Put this volume up. There we go. See, the place that's best would be where? Yes, that's it there. That's the best spot. So this thing is providing the oscillator frequency over there. The front end tuning is not doing that much. Okay, you get the idea. So what I have to do now is continue what I was doing. Done the front end. I'm going to continue to the oscillator section, oscillator mixer, check for component values, check connections, check for any shorts that might happen on here. I believe I know the oscillator is not working because when I produce an alternative oscillator frequency, it's all working well, reasonably well. So something's wrong with this oscillator section. It might be the transistor itself. I've got a spare for those. I've got quite a few of them actually. So I'm going to do exactly what I did there, continue on, and then we'll check again. Well, folks, I've got some good news. Listen to this. We've got FM back, and it seems that everything is tuning. Now, of course, my whole range is out. I don't know where this is starting and where this is ending. I can tune the oscillator here. And I can tune the coil there as well. So I think I've got it. What I'm going to do next is I've got to put this thing back in. Put the volume off. In fact, I'll switch it off. Now, I did quite a bit of cleaning up of contacts. I checked the components. The only one that showed up is, as expected, the transistor, which is an AF125. And when I measured it, strangely enough, on my cheap checker, it was telling me that this thing was an NPN, which is a bit strange because this is a PNP transistor. So I put it on the other checker, and it was giving me an NPN, and then it was giving me just a diode. So I replaced it and got this back. It didn't come back straight away because obviously this whole thing was out of tune. You know, you've got to tune the oscillator circuit to give you from 88 to 87.5 to 100 and, what is it, 104 on this thing? I'm not even sure. And then you've got to tune the front end to give you a nice broadband on that band. So this whole thing is out of whack. And I was actually quite fortunate to get a station and then started bringing that station to the middle of the range so I could check for stuff to the left and right. Now I've only got the antenna, one antenna connection connected to one of the whips. Everything is still pretty precarious here. So what I need to do next is to neaten this up. And folks, if I've told you before, I don't like working on FM front ends of tube radios, these things are worse. This thing is a bloody nightmare. This thing is, everything is so close together. The tracks are so fine. This thing had big blobs of solder on here. I'm still going to do the final cleanup. But what I'm going to do is I'm going to clean it up. I'm going to put it back in its place. And then I'm going to try and do the alignment to get this thing back on track. I need this in the radio so I can follow the instructions. Get the oscillator limits right. Get the front end tuned. Yeah, and then do a final test. But I'm not really looking forward to this part either. This entails getting it all in there, removing these long wires and connecting the original wires to those pins over there. So it should be fun. It should see me busy for another night or two. So what I'm going to do is I'm going to cut the video here for now, and I'll get back to you when I've got this thing all in place, and hopefully it'll be good news. I can give you a final inspection of this thing, because quite frankly right now it looks like a total mess. And this lady deserves better. Okay, well, I hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon or PayPal. Once again, thanks for watching. Bye for now, and stay safe.